this file. Now, possibly we have already learned about the structure of this file, how I compose it. Now, what we are doing is, we are calling all the libraries as required for this deep learning work. And later, next step is reading the data frame. I have the data frame, converting into data frame, and my data frame is now LS. Okay. And here I am looking the top 5 lines of the data frame just to make the confirmation, my own confirmation. And ls.info is just all the information on the data frame. And this particular task is okay. And here I am particularly choosing those columns which are highly relevant to my deep learning or predicting the lattice constant. Okay. And for particular that I am not reading the those values which are my target. My target is ABC. Okay, and in the top line number here, features are the RA, RB, FA, FB, and ZA. These are the features, and you can apply same methodology for any crystals that you want. Suppose you want to study double peroxide, so you will collect data accordingly. Or you want to predict the properties of chalcodenides, you can assemble the data accordingly. Or there are different crystal varieties. That is, if you know the workflow here, you can immediately apply to them to your research project. Okay. And these are the features, these are the targets, and try to make yourself habitual about these two things: features and target. Target, what we predict later on, and features, what we feed to the computer or our model, put to our model. Okay. And this particular type of deep learning is supervised deep learning. Supervised means first we are teaching what we will tell the computer, and then computer will begin predicting now. This is supervised learning. Like all we learn in a classroom, we go classroom is a supervised learning. If you do your final exam without even seeing your teacher or classroom or college, that is unsupervised learning. Like the learning of A plus A was unsupervised learning. But learning was also supervised learning. As an ancient example. So you have all the names, two names, right? What I just took. Evape and Arjun. Arjun's learning was supervised because Dronacharya was always with him. But Eklavya once he saw Dronacharya, but unfortunately when he took the finger, so he couldn't apply his knowledge later on. But anyway, his learning was unsupervised learning. That is how the supervised and learning. And here this particular learning is supervised because initially we are telling our model that if this crystal is that, suppose if the crystal has value of RA equal to this, value of RB equal to this, and and it has value of A is that, we are telling if this is the condition and RA, the lattice function A will be this, or B will be this, or C will be this. Okay, we are telling first from the 80% of the data. And we are testing, immediately we are testing, asking a question to the model that, okay, so this is 20% of data you haven't seen, okay, this is the condition, tell me the latest function. That is what we are doing here in most of the 1, 2, 3, 4. But in why 4 is different is because in the particular number 4 example, I am doing double precision calculation, double precision type of lattice function. That is evident by this one. I am changing that value which are ABC are those variables and a double precision variable. And if you look carefully on the earlier example, it was single precision. Although it may or may not benefit the training, we want to see how it works, and we will close this session for today. Okay. So you can also keep running those cells if there is no error message on your installation. Let me run live in front of you. So this is not error, okay, by the way. This is just a message anyhow, not error. And I am reading my data frame, top pipeline, and further information about my data frame. And I am separating my data into features and targets. On that is constant this time, okay? Not B, A. Very carefully, here is the A. And possibly there is comment. One target at a time. And in the second run, you can change that to B. And in the third time, you can run that to C. Because in our operations, A, B, and C are different. So, if you are like computationally smart, then you can run all three targets at once in single sweep as well. But I recommend not to do that because model will be very confused. Because you have to predict three things. If your social studies, English, and compulsory mathematics exam are on the same day, then you have in big trouble. Okay, you will definitely in big trouble on that day. So it is not recommended. So you predict A value at one time in one run, and predict a B value in another run just by changing that value, and run C in the next run. So in that case, your prediction will be better. I will show you that one later also, okay? How it performs. Now did I run this detail? Now this is normalization. I already explained you what is the meaning of normalization. And now I am splitting data into training vectors and validation vectors. And this is only stuffing criteria which we already know. And here my criteria is very loose or let's say very tight. If I begin learning, if my improvement is 0.1%, this is actually 0.1%, what is it? 0.001 is 0.1%. Then I will continue my learning. And at least I will learn, I will read that book for 300 times. And if 300 times process, the second is first, okay? It has some hierarchy of only stopping criteria. Patience is the highest in the world because that much iteration must go. If I am determined to read for 300 times, I will definitely read. And after that, if my improvement is less than 0.1%, then I will quit. If it is better than 0.1, I will continue reading the book. Or if you cannot afford that calculation, reduce this or reduce the area as well. Okay, it is up to you. You can select different value here, but do not go 0.1%. That is really what to do. And there is no appreciable learning. 0.1%. 1% is extremely standard value. If you improve 1%, you have to very happy in subsequent reading. But 0.1% is if you can afford that, you can go. Okay, but at least one time you can play that game. I would say it's a game. So let's do a very tough work. We are tired, but computer never tired. It will tire only if and it stops moving. Okay. Our motherboard is too hot or your processor is too hot. By working, it will never tire. Now this model is also bigger. You might have so many hidden layers. And if you cannot write this many hidden layers by hand, then you can make a loop of hidden layers also. That is also possible. So when you want 1,000 hidden layers, in some cases, then you can write 1,000 lines. Even copy paste is boring for 1,000. So you have to write hidden code as a loop so that it will be there will be values of 1,000. Okay? You can just define those loops in a hidden layer in the loop. That is also possible. Because of like the same 15 hidden layers you can type or even copy paste is not effective at that case. So this is my model. Now I compile the model. Now I begin. Now let us have a look on this part. What I am doing. My batch size is 64 because it is very good for my memory and our data is also not big. Just 100 data are there. And my parents told me to read 2500 times, but I have reservation for 300. Yeah, this is my reservation. My parents tell me. Okay. But even if whatever that, there's all people say me, I don't like to be here. So you have your own reservation. Okay. So let's listen to your parents and nothing came. What happened here? Bhagavad is zero. You are reading total silently. You don't know which epoch you are going on, what is your loss of validation or what is your loss of trading. Because your Bhagavad is zero. You are closing window and door and sitting inside the room and learning. If Bhagavad was one here, then it will show some sort of output. And for debug purpose, that was very useful. For production purpose, you can say Bhagavad is zero. For testing, debugging, it is very useful. Even you can write. So it will display more outputs so that you can figure out what's going on inside during the learning phase. Okay. So what here I set to zero and I can't see anything now. But as long as I think it's finished. Wow. Did I learn? Yes. Okay. Yeah. Once you see this empty circle right here on the kernel, okay, then remember your calculation finished. Okay. If it is busy on computing, that this circle will be black. That is one good hint, at least. Even if velocity is zero, this is very useful. Like it will appear as a right top corner of the screen. So now let me plot my learning. So now in this instance, it is accommodating all those losses, okay, and it will show us this way in a graph, nice graph basically. And you see now the when it is busy, this circle is black. Okay, you might also see in your screen. This circle will be black when it is busy. Once it will be white, the plot will display here. Let's see how it works. And particularly in virtual machine, it might be very tough, okay? Because virtual machine is not so efficient as a hardcore computing like this. So we have the data now, and you see here is white again. The circle is white. So you are going beyond slightly beyond 500 epochs, and you start learning because it fulfills your criteria. But unfortunately, because of the velocity is zero, I cannot read the output directly on the screen. Okay, this is how it works. And finally, to understand the event. So while predicting lattice constant A, I am 2.8% F3 error is there. This is the meaning of this logic. So somebody should note down this, okay? 2.834. I think 3 digits are enough. Don't go more than 3 digits. Now let's change to B. We can do this also. Now from here you have to do all the steps, okay? First save this file and run. And now I will do velocity 1 because I did that mistake last time. And I was totally blind what's going on. Okay, so I will not do that mistake now. Now I did velocity 1. Or let's say 2. Why not do 2? Because 1 we have already done. Let's change that to 2 velocity if it is allowed. You see, now I am trying to go 2500 equals and some of the equals are going on here. Okay. So definitely outputs are little bigger this time, or I guess. Or there is no velocity 2. And don't worry, calculation did not finish, okay? Because there is a blank circle here. It is keep on going. Now I am around 382. Keep on going. So are you also able to follow this example on your own on the laptop? Okay, if you have any problem, just raise your hand, okay? After this, we will receive is already 5:15 as well, right? 5 o'clock in Indian time. Yeah, it's still going on. Looks like I have to read it at least 1,000 times here. It is even 700 now, 800. Yes, 96. More than 900 times. Let's see, if you listen your parents, then what will happen? Let us see that. This is the idea of listening your parents. And if all the criteria does not meet, then it will go to 2,500 class. Okay? Remember that thing already. If criteria did not match, you have to read 2,500 times. Yes, okay, good, very good. After 200 equals, my calculation is done. Okay? So we did the only stopping criteria, even plotting every time. Okay, plotting will take around 3-4 minutes. Because there the columns are very big and it has to take value one by one. Yeah. Now, this time, slightly improvement or this improvement, let's see the minimum of this. Oh, this is bad. On this, I am not better than 3.8 9% almost. So prediction of this is complicated than that. Okay. And in the same way, you can take prediction of C as well for that feature. It is definitely not good than A. Okay. Let's take the C1 now. How better we can predict. And for this, I will do 1 to 0. Because I don't like it. Let's back to 0 and in the what do we want to see? From B, now I am predicting CL. Okay. Let's save. And now we run. Running. And there is other things we have to do. Now I check. This time this circle is partially black. What does that mean? Because you run 2 cells without finishing 1 cell. Okay, so it is going to this kind of method. Yeah. Now my calculation finished. Let me plot. Let us run the last one. So remember this is 3.87. Okay, the previous one. Prediction of C is better than B. Okay, and it is the best one among A, B, C. Prediction of C is the best one. So this is how it works. And I will give you one option because my data are 100 lines. So I want to clear all the data in single shot. That means I have to increase my page. Sorry, batch size from 64 to 128 so that I can put all the data and that plot sometimes is better. Let us see that one. Okay. For the same. What I want to do is I do not want to change it any other way. Only on the training time I want to change. Here in the actual training time, I want to increase 164 to 128. So if my batch size is 124A, then I am feeding all 100 data in one sweep. Before it was doing two sweeps because of the sum of 64. Okay. So now my data is just 100 points, even 80, not even 100. So I am feeding all the data, although there is only 80 values, but anyway I am feeding in a single class. That's it. It might improve the performance because if you go one by one, you might forget what the previous told and what the next told. But if you ask all the class, what is this? Then a common voice will come by 70. So that might be more reliable. And machine learning does the same thing. Exactly. There is no question. Okay. So let's do this. Now I am training with 128 batch size. That means I am training all my database in a single class. Let's see how it goes. And in tomorrow's session, we do the same thing in a more crazy way. More crazy way in the sense that we might increase the batch size, we might increase the repos, and our sample is not 100, our sample is 1300 or 4800 like that thing. So we will be working tomorrow on supercomputer, and your user ID is already created. Narendra will share that Excel sheet with you, and you will identify what is your user ID. Okay. And morning session, we will have some idea how to assess and submit job and read the data. And on that particular, I will make second set of data because we are not doing live like this. We will be doing in a batch mode, means supercomputer is in Kathmandu, 3,000 kilometers from here, and calculating live is very difficult. Because right now we are working on our own laptop and working live is very good. But in the remote machine, it is not recommended and mostly impossible if your bandwidth is limited. So we will do a different approach tomorrow, and you will get a new and actual way of working on supercomputer. That is the actual way. Right now we are very lovely, doing very lovely. This is called lovely. You are working on the same laptop and you are seeing your results live. It is lovely complicated. Okay. But tomorrow we will not do this lovely stuff, and we will do the real way how we do. So I was increase the batch size, okay? That is what we did, and let's see the result now. Remember last value, okay? 2.642. I think 3 digits are enough. Remember. 2.642, okay? Somebody should quickly note down this value. Also, generally, results are entirely different now. What is happening here is my batch size is big now, and this has different consequences. You see the result here. If your batch size is bigger, it is learning very good from the very beginning. The learning is really good from the starting, right from the starting. And its repos are also less. Before it has run 1200 times to get the accuracy, desired accuracy. But now, after 305 or 10 repos, it is stopped. This learning is better. Okay. Now let's see the result. Learning is better means computation is faster. When your equal size is bigger, your computation will go faster at the cost of bigger RAM. If you have bigger RAM, you can increase your RAM size. Okay. Because my laptop has 64 GB of RAM for now, but some of the RAM is used by the notebook browser and other stuff. But still, I can, on the size of this data, the columns are not that much, just few like 6, 7. So it was very good to use the highest equals as much as, sorry, highest batch size as much as possible. Here is the result. No, I'm not. Yeah. Okay. So I think I have given you enough hints. I do not think I am making you smart or I teach you more, but I have given you enough hints definitely. And I hope you also agree with me on that part. So let us stop for today, and you can make your own database and play with the reference of these files. 6, 7 files are already here. You try to make your new file for your particular problem. Okay, that could be anything which you have seen and similarity you can carry and you can start working. And I thank you very much for your patience again. Okay, for your patience and learning rate. I hope I am at least increasing your learning rate by 0.1%. That was our only stopping criteria. So you achieved that goal, and now I am stopping the learning. Okay, on the language of this learning. Thank you very much. सर खत्म हो गया